Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I teach online seminars for exams PFM, LTAM, and IFM at Illinois State University. Information about them is at smarturl.it/BTDT-online. BTDT stands for the method of studying I think is the right one for passing professional actuarial exams. BTDT stands for been there, done that. This is what you should be able to say when you're taking the exam and you look at any problem on the exam. You have to immediately know what to do. There's no time for thinking on the exams. You have to look at the problem and know what to do with it. Be able to say, been there, done that. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students at Illinois State University, please go to smarturl.it/help ISU actuary. Here's a problem for today. You are given that the force of interest at time t is given by the formula delta sub t equals at cubed, where a is a constant. Find the present value of a continuous 6-year annuity with a payment rate at time t equal to bt cubed, where b is another constant. And you have 5 possible answer choices. It should be noted that all answer choices are formulas, so you have to write out the formula for the answer and then find a way to express it like one of the 5. So we begin by finding the accumulation function. A of t is equal to e to the integral from 0 to t of as cubed ds. The integral of as cubed is as to the 4th over 4, evaluated from 0 to t. That's e to the 1/4 at cubed, at to the 4th, sorry. And the present value that we're looking for is the integral from 0 to 6 of bt cubed, the rate of payment of the annuity, times the present value factor, which is the reciprocal of the accumulation factor, so e to the minus a over 4 t to the 4th. And then we more or less add it up, but it's a continuous payment, so that's why we take the integral from 0 to 6. Well, this is not an immediately clear integral. You can't just guess what the answer is. We try to figure it out. So I do a substitution here. I write u equals t to the 4th over 4. Then when t is 0, u is 0. When t is 6, u is 324. And du is t cubed dt. Okay, then t cubed dt becomes du. E to the minus a over 4 t to the 4th becomes e to the minus au. And this becomes the integral from 0 to 324 of b times e to the minus au du. Now we can calculate the integral. It's minus b over a times e to the minus au, evaluated from 0 to 324. At 324, this becomes minus b over a times e to the minus 324k. And at 0, this becomes minus b over a, because the exponential is 1. But it's minus minus in the result, so this becomes plus b over a. And this then can be written as b times 1 minus e to the minus 324a over a, which is answer C. Please remember this is copyrighted material. The problem was created by me, and the solution is also mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.